This is Jean from Linkurious, and I'm very pleased to welcome everyone to today's webinar, From Complexity to Clarity, Visualizing Supply Chains with Graph Analytics. So let's get started. So first, I'm delighted to welcome for today's webinar, Frederic. Frederic, can you introduce yourself? Yeah, that's Frederic. Maybe we'll let you figure out how to connect the audio section. Emily, maybe you want to say a quick word of introduction.
Sure. Hi, everyone. My name's Emily Williams, and I'm a customer success manager at Linkurious. So I help clients with their project, ensure their success with their project, and keep them updated on different product features, etc.
Frederic, are you here?
Can you hear me now?
Yeah, we can hear you loud and clear.
Sorry for that. I was just struggling with these buttons here. My web browser didn't allow some of this to take over the microphone. But yeah, Frederic Rameau, I'm a managing director at Alvarez and Marsal. I'm focusing all my energy on the automotive, industrial, and transportation sectors. And over the last few years, I've been leading a variety of efforts with the firm, internal and external, to bring graph technologies to solve complex supply chain problems.
Very cool. And as for myself, my name is Jean Villedieu, and I'm one of the co-founders of Linkurious. So with that, let's get started. First, a very quick word of introduction about Linkurious. As a company, we were created in 2013. Today, we have two offices, one in France and the other one in the US. We are a team of 50 plus employees. And on a daily basis, more than 4,000 analysts throughout the world are using Linkurious Enterprise to make sense of their graph data. We are working with partners such as Neo4j, Microsoft, and Deloitte, but we have also more than 100 clients throughout the world, including organizations such as Zurich Insurance, His Majesty's Revenues and Customs in the UK, Pioneer, the Street, Ria Money Transfer, and Airbus. So now let's talk a little bit about the agenda for today's meeting. So first, we'll discuss why graph analytics is critical to understand supply chains. Then we will discuss supply chain and graph analytics, concrete use cases. We'll walk you through some concrete examples of leveraging graph analytics in supply chain. And afterwards, we'll do a bit of a discussion of Alvarez and Marsal's advanced scheduling and supply chain optimization solution. And finally, we will have a demo for you of Linkurious Enterprise and supply chain. So that's it for the agenda for today's webinar. So let's get started with why graph analytics is critical to understand supply chains. First, supply chains are at the center of a very fragile global economy. We all remember that when COVID hit a few years ago, we experienced the impact of disturbed supply chains in our daily lives. We experienced that through shortages, price hikes, and inflation, for example. And this hasn't changed. I mean, the tension on supply chains throughout the world has only increased. The war in Ukraine and the growing tensions with China are also highlighting the fragility of some supply chains. For example, organizations need to comply with sanctions and bans on clients or suppliers. They also need to take into account the risk of being cut out from certain markets. All of that leads to the fact that managing supply chains risks is paramount for all organizations. And it's no easy task. It's no easy task because supply chain data is complex. Here we see an example from the automotive industry, and we see how complex this data really is. So on the left, you have organizational data. So we're talking about documentation, processes, facilities, but also hierarchy, KPIs and reports, and finally, systems and databases. So that's one silo, but there are other data sources such as all the product data. So that's product documentation, the processes, the product details, also the organizational hierarchy, and the bill of materials. You need to also take into account customer data. So that's data about individuals, but also corporations and customer relationships. There's event data, which is more and more prevalent in today's world with sensor/telematics data, information about warranty claims, customer contact information. This can be augmented with third-party data, data from dealers, for example, or from social media, and also market data. And finally, there's also the supply chain data itself with information about suppliers, logistics, and inventory. And all of that is deeply interconnected. So it's no wonder that for many organizations, it's a struggle to effectively manage their supply chain. As an example, 74% of supply chain companies are facing a shortage of critical parts and materials today. 68% of supply chain companies have products being held up in ports or across borders. And finally, 83% of executives say that their supply chain technology investments haven't fully delivered the expected results. So these paint a bit of a dire picture, as you can see. And I want to drive this point home with some concrete examples of how a limited understanding of connections lead to supply chain issues. And we are going to talk about three examples here. First, supply chain management. So you need to understand the connections across products, parts, components, suppliers, and compliance. And if you don't really understand those connections, then it becomes hard to do what-if scenarios. What if the production was to double? What if there was to be some shortage for this component? It's also difficult to manage risks and compliance issues. And in terms of warranty, here we're talking about connections between products, parts, components, claim suppliers, and clients. And not understanding deeply those connections make it hard to do impact analysis. What if a certain product needs to be recalled? It's hard to do that sort of analysis. Or it's hard to do root cause analysis. I'm seeing a lot of issues with a certain product. What is the most likely root cause for that? And finally, in logistics, you can have about connections between products, suppliers, warehouses, delivery centers, clients, vehicles, and understanding those connections is critical to optimize logistics in real time and quickly adapt to changes. What's interesting is that graph analytics can help analysts understand the hidden connections in their data to make better decisions. In the past few years, a new type of technology has emerged, graph databases, that are optimized for the storage and query of large, massive graphs. It makes it possible to unlock and cover insights hidden in complex quality data, such as the supply chain data. Here you can see how this event data, this supply chain data, the product data, the organizational data can all come together to form one big graph. At Linkurious, we propose a product called Linkurious Enterprise, which is a graph visualization and analysis platform. You can plug that onto a graph database where you are storing your graph data and quickly make sense of this data via search features, visualization features, but also the ability to detect hidden patterns in the graph. All of that in a platform that's compatible with the security, scalability, and customization requirements of large organizations. There are three ways Linkurious Enterprise can help extract insights from supply chain data. First, with Linkurious Enterprise, you have the ability to leverage the power of graph databases. So it's directly compatible with graph databases such as Neo4j, MemGraph, Azure Cosmos DB, or AWS Neptune. What that means is that you can analyze complex connections across billions of data points in real time. Second important aspect is that with Linkurious Enterprise, you can really bridge the gap between the graph data and the business users. Linkurious Enterprise is meant to be very easy to use, and what that means that you can deliver a solution in days that can be used by the business users to search, explore, and leverage the graph data and to make decisions, no matter how complex the data actually is. And finally, Linkurious Enterprise is ready to integrate into your business. You can deploy it on the cloud, on premise. You have advanced security options to make sure that your sensitive data remains secure. And our API is used by your clients to integrate Linkurious Enterprise with third-party applications. There are three aspects in terms of how you can use Linkurious Enterprise to make sense of supply chain data. First, there's the graph visualization UI that can help you get to the bottom of your investigations faster. Then there are features, functionalities around alerts and case management. You can detect and automate the discovery of some patterns of interest within your graph data. And finally, collaboration features help you work together as a team, share insights, and work more effectively. So we've talked a little bit about the use of graph analytics and in supply chain analysis. Now I want to walk you through some concrete use cases. So there are a lot of potential use cases for graph analytics in supply chain. Here we can see an overview of those various use cases. So first, there's supply chain optimization, and that's figuring out the best route, doing what-if analysis. There's also warranty analytics. What are the common factors of product defaults, for example? Or maybe you want to know if a given component of a product is identified as faulty, what products or clients are impacted by that problem. There's also Customer 360. You'll need to provide support to a client. It can help understand everything that this client is connected to provide the right support. Or you can use the same type of data to identify upsell or cross-sell opportunities. Another important type of use case is risk management. Maybe you have questions such as, am I too reliant on a given supplier? Or maybe you want to know what could be the impact of a certain supplier being bought out by a competitor. And finally, another type of use case is compliance. And here you may have questions such as, are the components used in my products coming from sanctioned suppliers? Are my clients connected to risky entities? Are there any risky substances in my products? So these are some potential use cases for graph analytics and supply chain. Now I want to dive deeper into this topic and share some examples of modeling your data to answer these problems. So here we have an example of a supply chain graph with various types of nodes in different colors. So in green, we have supply chain data. We can see some facilities, for example, contract suppliers, costs and countries, among other information. In blue, we have actual product data. Here we can see a vehicle connected to a product, an assembly, a vehicle order, or a component. We also have third-party data, such as market data and social media insights. And we have organizational data, such as sales figures or sales forecasts. So that's very much a supply chain graph. And we can use this graph to answer a lot of questions. For example, we can use it to better and more accurately predict the ordering needs. For example, based on the sales forecast, we can do the analysis of what needs to be ordered. We can also optimize the storage of components, also based on this sort of forecasting figures. So that's one example of one graph, supply chain graph, and the type of questions that it can help answer. Now let's move to another example. Here we are going to dive into a warranty analytics graph. So in this warranty analytics graph, we have in blue information about product. So we have a vehicle. You can see that it's connected to a product, to some options, and to a bill of material. We also have a lot of event data in purple. We have sensor data, telematic data. We have claims, fault, previous claims, and then we have also customer data and third-party data. So that's one way to model your warranty analytics graph. And this graph can be used in a number of ways. So for example, it can be used to identify if there's a faulty component or many vehicles are impacted by that, or many vehicles have that specific component. Or you may want to know what are the suppliers providing the parts a part that is oftentimes identified as faulty, to identify the potential root cause of a lot of claims. And finally, you may also use this type of graph to identify customers linked to a lot of claims with some potential for fraud. So that's a warranty analytics graph. And here is now an example of a simplified logistics graph. So in this logistic graph, we can see a simplified version around movement of goods with some delivery centers, some intersections and junctions. This graph it can be enriched with properties such as the inventory in certain locations or the average processing times in others. And then the graph can be used to compute shortest routes based on distance, cost, and other factors. So that's an example of a logistics graph. And now here is an example of a compliance graph. So in this compliance, I mean, if you're in the industry, chances are that your products must comply with some rules and regulations. For example, in Europe, we have REACH, which addresses the production and use of chemical substances and their potential impacts on human health and the environment. And you need to make sure that your products are not incorporating chemical substances that are deemed as dangerous. Here, parts and products can be linked to materials that can also be linked to substances and legislations, such as the REACH legislation, may address those substances. You can also have news articles covering one of those new legislation or covering issues or incidents with a given material or substance. Equipped with that, the graph can help identify, for example, if there are risky substances in one's products, or if a new substance has been recently identified as risky, and identify what products may be impacted by such a change. So we have seen a few examples of how to think about your data as a graph, and then how to use that to answer some business questions. And now for the next section, I'm going to leave the floor to Frederic to talk about his experience at Alvarez and Marsal.
Hello, thank you very much. And so I'm going to spend a little time getting a little deeper on very specific supply chain, and in particular logistics use of graph technology, and in this case the use of the Linkurious library for being able giving us a chance to manipulate and visualize the solution that we've come up for this complex problem. So as an introduction, one of the kind of guiding objectives that we have here at A&M when we work with our client on this supply chain problem is to help recognize that the way supply chain are constructed are really the results of an attempt by humans to deal with complexity. And as you think of this simplistic view here of an end-to-end flow, what you would see is that to make it manageable across organizations, across the supply chain, but also within organization, within departments, between warehouse and factories, there's a need to kind of break down the problem and then to create a bunch of different chain link that get connected, and at the intersection of those to create assumptions, if you will, on how a handshake would take place between the upstream and downstream side of the supply chain. And all these are designed to make it manageable within certain boundaries, and this entire process then lead to sales and operation planning and sales operation and inventory planning across these supply chains to define how it should best operate. As a result, and here at the bottom looks like we're missing a little bit of text, but the bottom realization of this is that by design, we create inefficiencies and waste in the supply chain. Essentially, an inventory level, unless everything is fixed and never vary at all in an end-to-end supply chain over a long period of time, your inventory levels is always, to some level, a source of waste. And the lead times and the minimum order quantities and so on are all designed to maintain, the operation across the entire system, and by design constitute waste. And so how do you allow this to vary in real time and to constantly adjust in the best possible way to minimize at every connections in the supply chain the existence of waste and wait time. And so double clicking on the middle section of this graph, the same problem exists within the logistics, part of a supply chain where you need to move freight. And within, if you dive deeper into the operation of such a logistics organization or a transportation company, you'll find the same thing, where the supply chain complexity is broken down between the sales and network design, operating planning, dispatching, and fleet operation. And there's a bunch of hands-off at each stage of that process, which create waste. So what we've done at A&M is recognize that the traditional methods of using digitization and digital tools and analytics are obviously extremely important. The use of these techniques and in the ability to take actions and react to problems in your supply chain is obviously very important. But we are focusing a lot of our energy in creating a third lever here, which is to create, using graph and graph analytics and graph visualization, a way to react to all this in real time. Right? And here's a concrete example of a logistics system which deal with hundreds of trucks, complex nationwide networks, trailers, a bunch of customers shipping freight across the country. And here, what we have done at A&M is created this solution toolkit that we call it, which has on one side a digital twin, and a digital twins, modeling capabilities allow you to model a complexity of a physical complexity of a network like this. And you can see here and read, right? We actually modeled every single location, every truck stops, every gas station where the trucks need to refuel. We modeled the traffic conditions and the transit time between locations. We calculate the hours of services of the drivers and make sure we know when it needs to take a break and so on and so forth. Right? All that is captured in a graph and visualized using these visualization libraries. And on the right-hand side, we do the same when it comes to the business logic that is required to run a business. And so there too, we use graph methods to build a rule engine that is essentially a series of use cases represented in the form of a complex decision trees. And these decision trees are made up of conditional nodes, action nodes, and decision nodes. And then we essentially model a number of use cases to be able to represent the way the business is supposed to operate, be it What do I do when I have a new order? What do I do if a truck driver is sick? What do I do when I show up for a pickup? What do I do when when I have a flat tire and need to repower a truck and so on? All these are use cases, and there's a number of conditions that needs to take place in order to make sure that you can execute those use cases properly. And then what our system does, the left side and the right side talk to each other. They actually kind of a graph to graph communication. It asks each other questions thousands of times a second to actually consider, okay, on the left side something happened, there's a change, there's a new order. Ask questions to the rule engine, say what should I do? It goes through a bunch of conditions, and then the digital twin then will then take that on and say, okay, that means that I could do this possibly. And then you say, well, when I'm done with that, then what? Then they ask again a bunch of questions. It essentially is kind of, the system is designed to model the future and create the possibilities that are there in order to address these changes and figure out what to do next, right? All those possibilities are calculated in seconds, and then we use traditional linear solver techniques to figure out, based on a certain objective function, what's the best way to move forward. And concretely, if you see here a picture, this is a Linkurious visualization of a network, freight network on the left side, and on the right side, it's kind of a rule engine builder and visualizer that kind of shows probably 20 different branches of decision branch that exist in this decision tree for a given use case. And at the bottom, it gives you some of the statistics on how fast this graph platform is capable to essentially do what an army of people would do over hours, if not an entire day, right? So here we have 1,000 to 1,500 loads per day. The system will automatically calculate load compatibility. So make sure that the system is considering connecting and optimizing the assignments of trucks based on freight that can be moved in a consecutive ways. And then in this case, we placed 30 trucks around the network, and in about 3 minutes, it calculated 27,000 possible week-long assignments for a truck. And then in about less than 10 seconds, figured out of those 27,000, what are the 30 best assignments that will maximize revenue per hour for the entire fleet. Right? In that process, the digital twin had a discussion with the rule engine where they ask each other 90,000 questions. Right? So that's what we do with these technologies, and when we deploy this for a logistic operator, it allows a shipper to actually become almost take over the operation of a captive fleet, because you eliminate dramatically the need for planning and dispatching and fleet management. It's all autonomously operating. And then for carriers and brokers, it gives them tremendous amount of improved productivity, where the system is capable to solve, look way beyond the corner and look at the opportunity to drive productivity. We typically see 20 to 30% improvement in asset productivity when we deploy a system like this. So that's it. That's the sort of things that we do at A&M, among many other things around our organization, where graph algorithm and graph analytics is playing a much bigger role in the way we serve our clients.
Thank you very much, Frederic. Now we will see a demo from Emily mixing Linkurious Enterprise and supply chain.
Okay, so in this demo, we're going to hop into Linkurious Enterprise, and it's connected to a database of a supply network in India. And we're going to imagine it's a supply network for the company I work for, Globex Manufacturing. So in this data set, it contains different supplier information, such as cities the suppliers are located in. There's a risk score assigned to the cities, and the connections and dependencies between the suppliers. So what we're going to see in the demo is we're going to analyze it through a risk lens. And we're going to try to understand the different dependencies that the suppliers have in case something were to happen to one supplier. What are the cascading effects? We can also see how we can anticipate the effects of our supply chain based off of location risks, like if there's a flood, or based off of different like time or event-based risks. And just in general, we're going to get a 360 view of the supply chain, and we'll be able to see how graph and visual cues make it much more obvious to see the different risks and risky suppliers in relation to Globex, my company, in relation to my competitors, etc. So we can go ahead and jump into Linkurious Enterprise. So here's the dashboard, and again, the scenario is I am a risk manager for Globex Manufacturing, and my data engineering team has given me a database for my supply network in India. So I'm going to go ahead and start an investigation in my risk management space, and that way my other team members on the risk management team can also view my visualization, add comments, etc. So we'll start out just by searching for my company, which is again Globex. So we'll add that node to the database or to the visualization. And we can see that I have 10 different first level connections. So I can expand those first level connections. So again, I see Globex, which is my company. I can also see I have a subsidiary, which is Globex Widgets. And then here I can see all of my different suppliers, which are numbered just for the ease of this demo. So already with using Graph and using Linkurious Enterprise, you can see the dependencies so much easier. For instance, I can see supplier 8 is a direct supplier of my company, but I also see that they're a supplier of some of the smaller suppliers. So let's say something were to happen to supplier 8. Let's say, unfortunately, there's a fire at supplier 8's warehouse. I can go ahead and use a supplier impact analysis query. And what this is going to do is basically expand and highlight in red any of my impacted suppliers and any of the impacted nodes. So with my data model, I also have cities as nodes to indicate where the suppliers are located. But let's go ahead, and I really just want to focus on which suppliers are impacted by this fire at supplier 8. And right away, I can see supplier 9 and supplier 5 are impacted. So this is a smaller database, but you can see, especially at scale, how this is helpful to immediately see the connected suppliers that are subsidiaries or suppliers of other suppliers. Also, as I'm getting these insights and as I'm investigating my data, we now have the ability for you to comment in your insights in our comment panel. So here I can keep track of my investigation, and I can say, fire at supplier 8, also impacting supplier 5 and supplier 9. And then here I can have a running list of my comments. And because this investigation is in a shared space, when my other coworkers, my other team members on risk management hop into my investigation, they can also add their comments. So let's go ahead and bring back our cities, and I'm going to select everything and expand all of the neighboring connections. So here I see some more data is brought in. I can see I have my biggest manufacturing competitor, which is ABC Company. And again, I can start to see some of the suppliers we have in common, etc. Each of these suppliers also has a risk score. So for example, supplier 8 has a risk score of 0.96. So this was calculated during the data enrichment process before the data was ingested, and now I'm visualizing it in Linkurious Enterprise. So with these risk scores, let's say I really want to understand where my riskiest suppliers are located. So again, in a table format, or if you wanted to do it very manually, you can click and see the risk score. But I want to see all at once where are my riskiest suppliers and what's their relation to the cities they're in, to my company, to my competitors, etc. So there's a couple ways to do that in Linkurious Enterprise. One would be to use dynamic sizing. So I can hop into the design panel and with the risk score, I'm going to dynamically size my nodes. So that basically means that based off of the property I have for my suppliers, I'm going to ask to size the nodes according to their risk score. So that again, it can become immediately obvious my least risky supplier with a risk score of 0.18 is a direct supplier to my competitor. And then we can see right away, it looks like my riskier suppliers are located in Bangalore and they are directly supplying my company and my subsidiary. So this is a great way for me to, again, visually be able to see quickly the position of my riskier suppliers. But let's say I want to get more precise and I don't want to just in general see bigger versus smaller, but I actually want to filter based off of a specific risk score. That's also super easy to do from Linkurious Enterprise. So let's go ahead and jump into our filter panel. And here I can filter based off of the risk score exactly. So this is setting the parameters of the risk scores that are available here. And then I can toggle to see just my riskiest suppliers. So just the upper bound risk scores of 0.75 up to 0.88. And again, it brings to the forefront all of my riskiest suppliers and where they're positioned in my supply chain. So let's go ahead, now that we saw where it's how you can see your riskiest suppliers in your supply chain, let's think about different event-based risks. So on my edges, I have a property and it's the delivery date. So this is letting me know when the suppliers are sending the supplies and when they'll arrive at my company. So I want to see kind of a timeline, a story of when my supplies are going to come in. So let's just focus on those edges. Let's turn off the city nodes and run timeline. So timeline, again, is a way for you to filter your data through the lens of time. So what I've done is basically filtered out any edges that aren't a supplier of, and I filter out my cities. And from here, I can see, again, the parameters of my data. So it looks like my deliveries are going to start in January 2020. So if I start from the very beginning, for example, we don't see any of my edges. And then as I progress the timeline, I can see the story of when my supplies are coming in. So this is really handy, again, if we're thinking back to 2020 and the pandemic, if I wanted to focus on a period of time when I know maybe the warehouses would have, like a stay-at-home policy, or if I knew there were some event that was happening during a set time period, it's easy for me to see what's going to be affected. So let's go ahead and clear timeline and bring back into view all of my data again. And let's talk about location-based risks. So we saw with timeline how it's easy to filter our data to get some business knowledge about when our supplies are coming in, how you can filter to account for a risk that might be taking place at a specific point in time. But what about risks that are geographically affected? So what if, let's say, we know that there may be a flood happening and the flood is anticipated for the south of India. I can turn on the geo mode, which will map my nodes with longitude and latitude on an actual map. And again, I can see if there's, let's say, a flood. Not only is supplier 22 affected because it's in the south of India, but it's also a subsidiary of supplier 11. So I can know that I might need to check in with my warehouse for supplier 11, even if they're not in that geolocation, but because I can clearly see that dependency. So I think I've gotten a lot of insights in just a few minutes. Again, accounting for floods, accounting for stay-at-home orders, seeing where my riskiest suppliers are, getting some competitive intelligence about if I'm sharing riskier or not riskier suppliers with my competitors. So I think I'm pretty much done for right now. I got the insights I wanted to. I actually think for when my colleague hops in, I might do this as a hierarchical layout. I think that might be even easier to read. So I can easily make this a hierarchical layout with the spotlight on my company, Globex. So here you can see it's possibly an even easier to read view of all of the suppliers and their dependencies. So I'll leave this for now. I know my team members are going to hop into it. And where I want to go now is look at my alerts. So we started an investigation. I knew the name of my company. I knew I wanted to investigate, but we also have another entry points into investigation, and that's our alerts. So alerts are queries that you would code, and you can set them on a cadence to run. So it's basically hallmarks, risky hallmarks that you really want to keep on top of. So for this alert, it's asking to pull my suppliers with a risk score of 0.08 every 5 minutes, 0.08 and above. But you can make more complex alerts, such as, create cases for suppliers that match X amount of dependencies, etc. So again, it's a query. You'd be putting into query the different risk hallmarks you're looking for, and then you would set how often you want it to run. So for here, I can see all of my suppliers that have a risk score of 0.8 or higher. I can also filter through my matches to make sure I'm keeping on top of the most recent ones, or maybe the oldest ones by toggling here. I can also look at matches that weren't reviewed yet and matches that weren't assigned. So right now it's automatically pulled up cases or matches to the alert that are open and unassigned. And from here, I can click into a case ID. I can see the name of the supplier I'm going to be investigating. And then from here, I can open up the case. And then you'll see we're back into a very similar investigative workspace that I had in my previous investigation. So I have timeline, for example, the filter panel, etc. And again, I have comments so that as I'm exploring my graph and as I'm getting insights, I can make my comments here. With case management, it helps you keep track again of emerging threats. So let's say this was a supplier that I needed to investigate because they were risky, but at the end of my investigation, I can dismiss this and I can say no risk found. And then from here, I can go back to my cases. Let's say I did find some risk and it needed additional review. I can go here and assign it to another team member. But for now, let's say there's no risk found, we're all good on the supplier, and we can go back to our cases. So there's a lot to cover with our alerts and case management. So I believe Cecilia has linked in our handouts portion. We're doing another deep dive webinar on this, on case management and alerts. So make sure you sign up if this is something you'd be interested in. So that concludes the demo portion. We'll go ahead back to the slides, and I believe we are on Q&A now.
Yes, thank you, Emily. So just as a reminder, if you haven't done so already, go ahead and submit your questions in the Q&A section. There's a few rolling in, so let's just go ahead and dive into them. Frederic, I believe the first one's for you. So it says the rule engine that you showed in one of your slides is based on Linkurious feature, or you made it at A&M.
It's a. I mean, we developed it using or A&M core, data schema and algorithm, and the front end is all Linkurious. So the way we manipulate the rules and the way we add, remove nodes, edges, all that. So all the visual interface with the graph is all, and the way we can, visually traverse it, it's all based on Linkurious libraries.
Perfect. Looks like the next one's for you too. Can A&M elaborate on how Linkurious alerts enable the identification and reduction of waste and wait time in the supply chain?
So, the algorithm that we build do that. Linkurious is used to visualize the results, right? At least that's the way we operate right now. So our system will use graph algorithm that we have written on a digital twin, and we've done multiple different versions. A digital twin is a representation of your supply chain. And then our system will actually do, as I mentioned earlier, it will kind of communicate with each other and look at all the possibilities and the optionalities, do the math automatically, comply with all the rules, and then give us the ability to run all the options through a linear solver, which then essentially optimize the results based on an objective function. And what we've seen is that the humans typically are not able to consider the complexity of these things, especially when there's several order of dependencies, when your decisions lead to results that leads to a domino effect, if we will. Very few humans can look at these domino effect past maybe 1 degree of separation. Our system will look at these domino effect, 3, 4, 5, 6, 7 layers down, and then we'll essentially calculate the best options to minimize, quote unquote, the waste that the objective function is supposed to calculate. In our case, for logistics, it's wait time for the truck, it's empty miles that you drive, and it's on time or on time deliveries or maximizing on time deliveries.
All right. Let's see the next question here. I believe this one might be for Emily. It says, do the risk scores include a brief description of the risk to provide additional information or insight for those analyzing the data?
Got it. Okay, so in our demo model, it did not, but that depends on how you want to ingest the data. So again, the risk score is something you would do during the data enrichment process. So that would happen before it's in Linkurious Enterprise. So it's something that you could do. It just depends on how you want to enrich your data.
Perfect. Thanks, Emily. All right, the next question here. How difficult is it to implement Linkurious Enterprise?
I'll take this one. So it's not difficult at all. I think a couple of weeks to have a solution populated with your own data and customized with in terms of styling, in terms of alerts, query templates that are, I would say, specific to your use case. So it can be very very quick in terms of results.
Great. Next question. How does your system integrate Linkurious between the digital twin and the rule engine?
So our system, that's for me, right?
Yes.
Our system works on a Tiger Graph graph database platform. And so the discussion between the digital twin and the rule engine happens deep into the engine. And so we have written algorithm that allows that communication to take place. And we have a solution toolkit that allows us to deploy that sort of communication on pretty much any sort of a digital twin framework and any type of rule engine, as long as we have condition nodes, action nodes, and decision nodes.
Okay. Let's see. There's another question here about the risk and how it's calculated, the risk score.
Yeah, so this is, again, something you would do before it reaches Linkurious Enterprise. So you have different options. You could use Dataiku, Databricks, etc. It can be based off of the location, the number of dependencies, etc. So it's something you'd want to explore during your data enrichment process.
All right, another question here. Can you share examples of clients using Linkurious Enterprise for supply chain?
Yes, so I can take this one. So I think digital twin, like Frederic was talking about, is a popular one. We went over kind of like a truck fleet supply route, but we also have clients using it as a digital twin on the actual manufacturing floor. So creating like a digital replica of what the flow looks like on the manufacturing floor, so they can try to stimulate more like optimal routes for the product to go through, see the dependencies, etc. Another use case, again, really honing in on the manufacturing floor, is the actual product design of the product. So let's say, your product uses screws, and then widget A needs screws, widget B needs widget A plus widget C. You can again start to see the cascading amount of different parts of the product you need to make the final product. There's also some risk management in that as well if there's a shortage of one component of that product. So there's a ton of use cases just under the supply chain and supply chain umbrella and peripheral cases. So again, definitely used in routes, manufacturing, product design, etc.
Thanks, Emily. Speaking of digital twin, there's a question here on why do you call it digital twin and not simulation? I'm not sure if Frederic or maybe Jean, you want to take that one?
You tell me.
I think it's yours, Frederic.
I mean, the left side of this diagram does not simulate, really, it's not capable to simulate anything. The digital twin is a graph representation of the physical nature of the network, right? So it actually has just almost a digital copy of what is, in the real world. And so it doesn't simulate. What simulates is the dialogue between the digital twin and the rule engine that's capable to say, well, what will that layout look like in 3 days if these things happen? And then it needs to go through a lot of a question and a sort of algorithm to be able to say, okay, in 3 days that digital twin will look like this. Or at least that's one option. And then we create 27,000 of these, right? But the simulation is really not, embedded into the graph schema itself.
Thanks, Frederic. There is another one here for you. How many users, order of magnitude, do you, A&M, serve with Linkurious?
We build a solution for clients, right? So at the end, we turn over the code and we have our clients run. So we provide solution toolkits. We have a team that is specialized in doing this. We have a pipeline of clients, but at the end we help our clients embrace the technology and they become Linkurious clients and they run on their own.
All right. It does look like that's it for the questions for today. So again, we want to thank everyone for joining us and to you, Frederic, for being our guest speaker today. We did record this webinar, so we will send it to you as soon as possible. So thank you all.
Thank you very much.
Thank you.
Thank you.